Oh, welcome back to another exciting episode of How to Do Stuff with Mr. Stevenson. Today, we're going to be talking about area of parallelograms. So what's a parallelogram? Well, maybe you know, maybe you don't. Before we get into what a parallelogram is, let's define some other terms. Some other fairly important terms that I'm going to get into. Let's go in order here. The first one is a polygon. When I use the word polygon, that's a word. That's a geometric word. That means a closed plane figure with three or more sides. A plane figure basically means it's two-dimensional, and the object has to have three or more sides. And closed means it's closed. For example, here are some polygons. You'll notice some of them have lots of sides. This one has the minimum amount of sides. This has 3. So all the objects are closed. See how that is? They don't have any openings. Those are polygons. Examples. Here is a picture of some shapes. Let's try to figure out which ones are polygons. How about A? Is that a polygon? Is it closed? Well, it already violates that rule. Not closed right here. It has an unconnected side, so that can't be a polygon right there. So we'll cross that one out. Take this, cross that out. Is this a polygon? Yes, it is, because it is closed. All the sides connect with each other. It has several sides. It has 3 or more, so that works, and it's two-dimensional. So yes. That one is this. In the drawing, I think it's meant to be a 3-dimensional shape called a cube. So to be a polygon, it'd have to be 2-dimensional. So that one is not. Is this? Well, by definition, a polygon has to be made out of straight edges. It doesn't say that here in the definition. A closed plane 2-dimensional figure with 3 or more sides. And so the 3 or more sides are made out of line segments, we'll call them. And since these curve, that isn't going to work. So again, we have another one that is not a polygon. This one obviously is. It's closed. It's made out of sides that close it up. It's 2-dimensional, has 3 or more sides. So yes, that one is. This one's really nutty looking. Is it closed though? It is, so check that. It's 2-dimensional, check that. It's made out of 3 or more sides, so that checks out. Here is another one that checks out. All closed, 2-dimensional, 3 or more sides. I think this one is trying to say that it's not, it doesn't have the lines connecting. So this one probably, going by what I think I see, that's probably not, even though a triangle itself is a polygon. So that one right there is a little bit tricky. Here's another one. Is this a polygon? This one's tricky. We won't study this year, but this one is considered a polygon. It's called a complex polygon, the way it's shaped like that with the 3 triangles all connected together. But the definition fits for this one. And same with this one. It's basically a rectangle inside of another polygon. So yes, those are what polygons are. The next definition we have is the definition of a quadrilateral. The next one is a quadrilateral. And a quadrilateral is any polygon with 4 sides. So again, it's closed, it's 2-dimensional, it's made up of line segments that have 3 or more sides. So as long as it has 4 sides, it matches the definition of a quadrilateral. Well, lots of things are quadrilaterals. Here's some right here. As long as they all have 4 sides. There's other ones missing here, like the classic looking rectangle. Those are by definition all quadrilaterals. So let's review our area formula. We use the area of a rectangle as length times width, or another way of stating it is base times height. You can use these as interchangeably. We'll use both in terminology. So Well, since we're studying parallelograms, we have to know what parallel means, and I think most of you do. But if you don't, here's a little review for you. Basically, parallel means two lines that will never intersect each other. So here's two lines right here. They are going to continue on into space forever, and if they did, they'd never intersect. Intersect means they will never cross paths, like this. Okay, this is an intersection point. But for the sake of this, I would like to put that back to where it belongs, because that is what parallel looks like. So in parallelograms, so what is a parallelogram? A parallelogram, by definition, is any quadrilateral with opposite sides parallel. Here is the one everybody thinks of right here, if I can get it. So as you can see, the opposite sides of this quadrilateral, this shape, are parallel. So for example, if I use these lines and I just placed them here and here, that they would show you how those are parallel sides. And like I said, all the sides have to be the opposite sides have to be parallel to one another. Okay, so that's what a parallelogram is. Okay, in a parallelogram, opposite sides are parallel. And remember, parallelograms have to be quadrilaterals. They must have four sides. By definition, are these also this orange and this maroon square and this rectangle, are those also parallelograms by definition? Well, the answer is yes, because the opposite sides are parallel to one another. So these are all parallelograms because they fit the definition. Opposite sides are parallel, and they're quadrilaterals. So I'm going to get rid of those and put a problem up here, and we'll work this one together. So here I have your basic rectangle, and we've learned that to find the area of a rectangle, you take length times width, or in this case, we're going to say base times height, but they are the same thing, as you learned already. So when we talk base times height, we use that for rectangles, but we use that in a lot of different places, and we're going to be using that over and over throughout this unit. Now, if I were to split this rectangle and take and cut the end off of it into a triangle like this, and just take it and move it over to this side, look what I have. I have a parallelogram. Now, just because I did that, just because I moved that over there, does that change the amount of space inside here? I cut this off and I put it over here. That's a no. It doesn't change it. It just went from over here to over here. So the formula stays the same. It's still a base times a height. Now the height sometimes can be a little bit contentious. What's the height of a parallelogram? Well, a lot of people will want to say that this is a height, but it's not. Height is always straight up and down on a parallelogram. Base and height have to form right angles. So what I'm saying is this right here is the base, and this is the height, and they have to form this 90-degree angle right in here. Okay, so don't be fooled by drawings that don't have that. I can give you an example. Don't let anybody tell you that this can be a base and this is a height or anything like that. Okay, that's not true. That's not the base and the height. If you wanted to, you could turn this thing. If you look at it like this, take the shape, and this is something you won't be able to always do, but you know, if it's a 90-degree angle, even right here, it's not exactly a 90-degree angle, it's slightly obtuse. So in this case, the base would be right here. The height would actually be, so the height would be to the top here. I'll show you. Like this is the height right here. I'll move that slightly. That is the top of the triangle right there. Okay, and the height of the triangle would be this part right here. It would go from here straight down. That's the height, that's the base, that's the height of this triangle right there. So be careful, they have to form this 90-degree angle right here in the corner, this right angle. All bases and heights have to form the right angle. So here we have a parallelogram that has a base of 12 meters, this is the base, and a height of 8 meters. Using our basic area formula of length times width right up here, you would take 12 times 8, and 8 times 2 is 16, and 8 times 1 plus 1 is 9, so you get 96. So the area is 90, and we'll type it here. Put it right inside here. We'll say area equals 96 meters, and then I can put a squared sign on there because remember, area is always squared, and I like to circle my answer. Easy to see. So that's how you find area of a parallelogram. Hopefully you learned something from this. And if you have any questions, of course, let me know.